We will see susceptibility, permittivity and the dielectric constant of a dielectric material. So here we consider a linear, homogeneous and isotropic dielectric. Homogeneous and isotropic dielectric. So before going further, let us understand these three terms. A linear dielectric is a one where the relation between P and E as well as D and E is linear. So here the relation between P and E and the displacement vector and electric field E are the linear. So there is a directly proportionality between these two terms. Okay. So we would then write equations like D is equal to epsilon E and P is equal to epsilon naught chi E into E, where chi E and epsilon naught are constant. Means this chi E and epsilon are the constant at a given point for the dielectric. And now the homogeneous dielectric is one where the electric properties do not change from point to point in the dielectric. Here the homogeneous dielectric means what? There is a properties, electrical properties does not change from point to point. Okay, the values of chi E and epsilon do not change from point to point in a homogeneous medium. So in an isotropic dielectric, the electrical properties do not depend upon the direction within the dielectric. The values of this chi E and epsilon are the same in all directions. Okay, so as mentioned earlier, in a homogeneous dielectric, the polarization produced, this polarization is produced is directly proportional to the total electric field. So here this P bar polarization is directly proportional to this electric field producing due to this polarization, such that we can write P is directly proportional to E. So we can write P bar is equal to epsilon naught chi E into E bar. This chi E is nothing but it is a electric susceptibility. It is a electric susceptibility of the dielectric medium. Of this dielectric medium. And epsilon 0 is placed as a part of a constant of proportionality, such that chi E becomes it is a dimensionless quantity. We substitute P bar in the earlier equation. Which is earlier equation? That is D bar is equal to epsilon naught E bar plus P bar. We can write in this Gauss law in differential form. We can write we can write D bar is equal to epsilon naught E bar plus P bar is nothing but epsilon naught into chi E into E bar. So epsilon 0 into 1 plus chi e into E bar. Let here we can write epsilon r is the relative permittivity is equal to 1 plus chi e. Then we can write d bar is equal to epsilon 0 into epsilon r into E bar. Okay, so d bar is equal to epsilon 0 epsilon r into E bar. Let here epsilon is equal to epsilon 0 into epsilon r. It is nothing but it is a epsilon 0 into 1 plus chi e, where epsilon is the called as permittivity of a medium. This is the permittivity of a medium, and epsilon r is nothing but it is the relative permittivity of the medium. Then we can write dr is equal to epsilon into E bar. So this is the final formula. Okay, this epsilon r is here, it is a dimensional quantity and is known as it is a dimensionless quantity. I can write here it is a dimensionless quantity, and it is termed as the relative permittivity of the dielectric medium. This relative permittivity is also known as the dielectric constant K. It is the dielectric constant. K. It is equal to epsilon r 1 plus chi e, or we can write epsilon upon epsilon 0. Okay, here these entities k, epsilon r and chi e are the dimensionless and have no units. The units of epsilon are the same as those of epsilon 0, so which is c square upon Newton meter square. Okay, the dielectric constant K and relative permittivity epsilon r have the value of 1. Here this K and epsilon r have the value 1 for a free space, and at that time the electric susceptibility chi e is equal as 0. If we put these values in this term, then chi e becomes is equal to 0 for a free space.